This is part 3 in a series of videos in which I'm attempting to repair and restore this HP9862A plotter. In the previous 2 videos I've stripped the unit down, located and identified a few of the parts that needed attention, and as you can see I've given the base and actually the outer case as well a really good clean, inspected it. There is a bit of an issue with this, and it's not quite flat, it's got a bit of a bend, and this machine's had quite a rough life I think, so I've got a feeling it's been dropped at some point and the base is distorted. It's only about 1mm, so I can probably straighten this out when I bolt the power supply back in. Just push this down, tighten the screws, and hopefully that will hold it flat. I've replaced the missing feet on the base, it now has rubber feet all round. And as I said, given it a good clean. There's no real damage other than the slight bend to it, so I can now start to reinstall the components, and I'll work on them as I come to them. Now someone did mention that sometimes the videos seem to jump about a bit in terms of the sequence that I'm doing things, so it's worth bearing in mind that although I do try to keep the continuity of these videos as consistent as I can, bear in mind this work is sometimes carried out over several weeks or even several months, so while I try to keep the continuity as consistent as possible, there is always a possibility that there can be some inconsistencies in the continuity of the videos, but I do attempt to keep the continuity as consistent as possible, so bear with me if it seems to jump around sometimes. Just bear in mind these videos, as I say, can be shot over quite an extended period of time. Okay, so back onto this piece of equipment. What I've done so far, as I say, is cleaned up the base. I had to change the bays on this protective cover. So this is the cover that goes over the information panel that slides out the front of the machine. And the old one had, it's like a baize, foam backed baize material, but the original had completely degraded and all the foam had gone, but what's left behind is a bit like a coarse sandpaper, so it is important to change that, otherwise it will very quickly remove the writing from the information card. So I've done that. I can now start to reassemble this, so I'll get this bolted in and then we'll go from there. Okay, so I've got the information sheet refitted, that slides in and out nice and freely, and the next thing I'm going to do is refit the connector block at the back. You really need to fit this first because the rear panel hooks around it, so there's got this groove here and the rear panel sits in there, so although you can get it in afterwards, it's just easier to fit it now, and then just make sure that we slide the motherboard into it when we refit that. Okay, so I've got the rear block refitted. I've left it loose for now, so I can tighten that once the motherboard is refitted. Also, I have cleaned this and checked that it's not cracked and doesn't need any repairs. So that's the basic part of the chassis reassemble. What I'm going to do now is get this out of the way, and we'll get the transformer and capacitor block on the bench, and we'll have a look at that and make sure that doesn't need any repairs. Okay, that's this unit dismantled. This is just the transformer and capacitor bank, and what I need to do now is give this a good clean. I need to straighten this bottom plate. It's got quite a big bend in it. I suspect this unit's been dropped at some point, so I'll get that straightened out, get it cleaned, and what I'll do then is test the capacitors. So I'll test each one in turn. The way I test these is I connect them from an AC source, a transformer, through a bridge rectifier and to one of the Cumkin electronic loads. And I do that to subject them to ripple current. I want to make sure that they're not going to overheat when they're in their normal operational mode. So I'll do that for each of them in turn. They all obviously need to clean as well, so they actually look okay. I can't see any signs of any distress or bulging or anything that gives me cause for concern. They all look fine. So no signs of the vents starting to open. But as I'll test them, I'll leave them on test for an hour or so, and make sure they don't start to warm up, and at the same time I'll get this cleaned. I'll get this reassembled. I won't show that on camera, but once I've got it partly assembled, I need to refit it to the chassis. For some bizarre reason, there's a screw that holds this to the chassis that's underneath this left-hand block of capacitors, so I need to refit this to the chassis before I fully reassemble this. But then once this is done, I can apply power to it and we can start to bring some life back into the plotter. So all the capacitors tested good. I've started to reassemble this. I've straightened out the plate, was quite a bend in it, and given this a good clean, done a resistance check on the transformer, and as far as I can it seems to be fine. So what I need to do now is to get this bolted back into the chassis, and then we can refit the other capacitors and the clamp, and then refit the rear panel. Okay, I've got this assembly just resting in the chassis for the moment. I've made sure that the insulator is properly located. It needs to hook over this post. I haven't refitted the rear panel yet, and the next thing I need to do is refit the screws that hold this into the chassis. As I said, there is a slight bend to this, so I'll be pushing the chassis down to flatten it while I tighten these down, and hopefully that'll help to straighten it out, and then hopefully the weight as I add the rest of the parts will cause this to go completely flat. So we'll just refit the screws, not too many of them. I'm going to leave the front ones out for now because these hold the cover for the hold down voltage generator, so I'm just going to fit the rear ones. Okay, so that's all the screws fitted, and it has done the trick. It has flattened down the chassis, and all 4 feet now contact the bench. So that's that problem sorted out. I did temporarily fit the screws at the front just to make sure the holes line up, because there is a bit of adjustment in this and I didn't want to get the whole thing bolted in just to find I couldn't then fit the front screws. Okay, so now that's done, I can refit the capacitors. You have to do this first because of this screw that's underneath them. So these now go down into this position. There's one at the back, and I can refit the clamp, so I'll get that fitted. Okay, that's all bolted into place. I can now drop the rear panel into position, making sure that the wires are behind the protective cover. You don't want to get those caught and any of them damaged. So I'll do that off camera so I can turn the thing around and get to it more easily. And once this is done, then the next step is to get the motherboard, get that cleaned, inspected, and we can get that refitted and go on from there. I've given the motherboard a good clean. I've inspected all the contacts, checked the underside for poor connections, dry joints, that sort of thing. I've looked for any damaged tracks. I can't find anything that is cause for concern. I've checked the resistance of all the pots on the front panel. I've checked the continuity of the power switches, and it all seems fine. So far I can't find any faults with this. Given it a clean. Also cleaned the high voltage hold down generator, so that looks fine. What I can do now is manoeuvre this back into the chassis. It's just a case of making sure that the contact goes out through the clamp block, and all the wires are correctly routed and nothing gets caught, and then I can bolt the front panel back to the chassis. So I'll get that done, and we'll go from there. Okay, that's the motherboard dropped back into position. I can't fit all these screws yet because the ones at the front and back hold the cage in place, the PCB support cage. I've checked all the wiring to make sure I haven't got anything trapped. Can't bolt the rear panel back in, that's held in with the hinge bar screws that hold the top cover on. What I'll do now is get all the wires reconnected, and I can refit the cover over the high voltage generator, and we can then start looking at refitting the cage. Not forgetting, of course, the insulation pads that fit at the front and back that protect the motherboard from the cage itself. So there's one that sits at the front, one that sits at the back. I want to clean this before I refit it, and that's, as I say, just to make sure that the cage doesn't short out the motherboard. But we'll get these reconnected, and then we can refit the control panel and the electronics cage. So I've got all the wires reconnected. I've double checked them to make sure they're in the right place. I've cleaned up the insulation pads and dropped those into position, put the cover on the high voltage generator, and we're now at the point where I'm going to apply power for the first time. So I'm going to be fairly cautious as ever. Now initially it's not going to do very much because the rectifiers and the feedback to the capacitors is actually from this board that plugs in at the rear. And obviously that's not yet there, so I'm going to just here test the transformer first. So we'll power it up. I have checked to make sure it's set to 230 volts, so that's fine. Power this up, and I'll run it up to about 150 volts. I'm not going to take it all the way up to 240 simply because without a load on it, it could cause the transformer to overheat. It'd start to hum a little bit, but current's not too bad. We're only drawing about 10 milliamps, so no sign of any shorts. There's no smoke. So what we can do now is just do a basic voltage check for the transformer, and we should have a number of supplies. So most of them are double-ended, so we'll start off with this one. So this is plus or minus 17 volts. It's actually marked on the board as to what these are. Now this will be a bit low because I'm only running this at 150 volts, so what I'm looking for is symmetrical voltages to make sure there's no shorts on one side or the other of the winding. So we're getting 13.3 on that side, 13.3 on that side, and we'll do the same thing over here. So 5.6, 5.6, and then finally we have this one, 10 and 10. So that's looking good. What I'm going to do now, I'm going to leave it on now for about an hour and just make sure that nothing untoward happens. And assuming that's okay, then what I'll do is move on to the power supply board. I'll bolt in the front control panel, and once we've got the power supply tested, we can start looking to refit the various boards. We'll have a quick look at the power supply while this is running in the background. I'll move this somewhere else and just leave it running, and what I can then do is start looking at the power supply board and see if we can do any static testing on it. Okay, so these are the two boards we need to be looking at. We have what they refer to as the rectifier board, and this does all the initial AC to DC conversion, and also is partially responsible for some of the supply regulation. And then we have what they call the power driver board. Now luckily I do have the schematics for these. They are available in the service manual that you can find online for these. So what I'm going to do here is just do some basic testing, just check the capacitors, check the diodes, make sure there's no short circuits. I'll check all the fuses, of course, to make sure they're all intact. And I'll do the same thing for the power driver board as well, and make sure that is appearing statically as it should, so there's again no shorts anywhere. And what I can then do is plug these boards into the chassis. I'll start off with the rectifier board. There are some test points indicated on the schematic, but they're also shown on the board itself. So we have minus 17, plus 17, minus 19, plus 19, and plus 5. That's the unregulated plus 5 volt rail. Okay, so what I can do now is get this tested, and then I'll get this back in the chassis, and we'll see what happens. Took me an hour or so to test these, and by that time the initial soak test on the chassis transformer should be complete. Okay, I couldn't find any faults on either of the two boards. Doesn't mean there aren't any, but the next thing is to try and power it up, and we'll start doing some dynamic testing. So I've got the rectifier board plugged back in. If you can't remember where the boards came from, just remember that they are color coded, and so you can look at this and make sure that you've got the boards in the right place. So this is the grey one, so it goes on the right hand side. So next thing is we'll get the power applied using this through the bench variac, so I can bring it up fairly slowly. And what we're looking for is for the voltage to come up to around plus 17 volts. I'm on the plus 17 volt rail here, and also at the same time we'll be looking for anything overheating. I've got the thermal camera pointing at this as well, so I can see that. You can't see the thermal camera, but I've got it on a tripod that I can just keep an eye on it to make sure nothing's getting hot over here, and that none of the capacitors are showing any signs of distress. And so next thing is to get this powered up. This is possibly the first time it's been powered up for quite a long time, so we'll bring it up slowly and see what happens. Well, the voltage is starting to rise, which is a good sign initially. Still only drawing about 10 milliamps, up to just over 100 volts, 110 volts. The transformer is starting to hum. That's to be expected because it's completely unloaded, so it is going to be suffering a little bit. We don't want to run it for too long like this. Okay, and the voltage has stabilized at plus 17 volts. So what I'm going to do is the same thing for the other rails. We've got plus or minus 19, and then the unregulated 5 volt rail. So I'll check that all those are behaving themselves, leave it running for a short time to make sure nothing's overheating, and then I can plug the power driver board in and check the regulated 5 volt rail. Okay, all the power rails tested fine. It ran for about half an hour, nothing really got warm at all. The transformer is kind of barely warm, none of the capacitors warmed up, and nothing really got hot on the board. I was inspecting it with the thermal camera every minute or so, and that looked fine. So the next test is to see if the power driver board works. So I've got the multimeter hooked up to what should be the 5 volt rail, and I'm keeping clear of the red lead. It looks like it's fairly close, but it's actually quite a long way away from the test clip. So that's the high voltage for the paper hold down. I'll be testing that with a neon bulb. It's just a very low current, high voltage supply. And so next thing, we'll get this powered up, ramp the voltage back up, and we should see this stabilize probably just a touch over 5 volts. So I'll keep an eye on the current as this starts to increase. Okay, so it's up to 5 volts now with 125 volts going into the unit, and the regulator should now start to limit that voltage, which it is doing, so that's looking quite promising. Again, the transformer starting to buzz because it's unloaded, but we are stabilized at a sensible voltage. It will be slightly high because there's no load on it, but what I'm going to do again is leave this on soak now. I'll probably leave this overnight with a fairly low load on it, probably 50% of its normal load, and I'll leave it like this. And the reason I do this and leave it for so long is because quite often you find these units actually work until there's an issue with the power supply, which is where most of the faults develop, and quite often they will damage the other boards, and then it's a lot of work to try and get those sorted out. And I also like to keep them fairly original as well, so I don't want to go blowing up parts unnecessarily. So I'm going to leave this running for a while, and probably come back tomorrow and continue from there, and we'll start plugging in the various boards and seeing how it develops. I'll also of course need to refit the top cover and the hardware so we can start seeing if anything can be driven, but we'll start initially by checking the processor, make sure that's actually running, and I'll do that in the next video.